Okay, so solving exponential equations. So I want you to think about a couple scenarios. The first being, I want you to take a look at the bases. So for example, let's say I have 2 to the third equals 2 to the x plus 1. Well, when you have the same bases and there's nothing else attached with any of them, we can set those exponents equal and solve. So I'm going to say set the exponents equal, because if the bases are equal, then the exponents have to be equal. So for something like this, it becomes an easy solve where I can say, oh, well, if 2 to the third is 2 to the x plus 1, then I know 3 must equal x plus 1. And this is a simple linear solve. One step, not too bad. Now, might get a little difficult if the bases aren't the same, but maybe I could make them the same. So let's think about this. And I'm going to put a little note here. Can we force the same base? For example, if I had 3 to the second power equals 27 to the x. Well, you may recognize right off that 27 is the same thing as 3 to the third, right? So I could change this a little bit and I could say, well, really, I'm going to write this a different way. And I'm going to say 27 is 3 to the third, but that x is still there. Well, because I know if I raise a power to a power, I multiply, my equation now becomes 3 to the second equals 3 to the 3x. Well, now I have an equation. The bases are the same. So I can simply set these exponents equal to one another, divide by 3, and solve for x. So fairly easy solves. Now, some of ours are not going to be quite as easy to solve. So what I want to do is I want to think back to some of my logarithm properties, okay? So if I have, I'm going to give you some steps here. Let's say we don't have same bases. To solve, the first thing that I'm going to do is I'm going to isolate the exponential piece. So let me run you an example beside here so you know what I'm talking about. If I have 5, well, that doesn't look like a 5 at all. If I have 5 times 2 to the x equals 30. And I want to solve this. Well, I need to get the piece that has the exponent with it all by itself. So right now it's got this 5 hooked to the front of it. So what I want to do is just divide. So I'm dividing here by 5. I get 2 to the x equals 6. So now once that piece is isolated, my next step that I want to do, and you may have to do more than just one step to it, but just remember to follow those backwards order of operations. Now what I want to do is I want to change the form. And I always tell my students, if you ever get stuck or lost in a logarithm or an exponential problem, see if you can change the form and it helps you get out of the mess you're in. So in other words, if I look at this problem, I say, okay, right now it's in exponential form. How could I change that to logarithmic form? Well, here, log, the base is 2 of 6. Remember, logs are exponents, so they always equal the exponent. Well, this is a pretty easy solve. Now I'm going to get a decimal approximation, but that's fine, because at this point I can use my calculator if I need to. And so I'll put if needed here. And simplify. So remember, this is not a base of 10, so I'll use my calculator to say log of 6 divided by log of 2. 2.58 is going to be our approximation. So I just want to show you one more example that's maybe got an e in it in case you haven't seen the e function. And maybe it's even got a little extra something up here in the exponent. So again, I'm solving an exponential, so I want to isolate that exponential piece. This is my exponential piece. So I need to get rid, remember I'm opposite or backwards order of operations when I solve, so I want to get rid of this 8 first. So I've got 3e to the x plus 1 equals 9. Again, just trying to get that exponential piece by itself. Divide by 3. So I've got e to the x plus 1 equals 9 divided by 3 is 3. So now that it's by itself, you might say, I don't know how to change the form on that. And you're wrong, because you do. If you look at it, and I'm going to come over here because I'm running out of room. I've got a log. Remember, your base is what's hooked to the exponent, which is e, of 3. Logs equal exponents, so it equals x plus 1. Now, if you think back, we have two types of logs. We have the common log, which is a base of 10. We have a natural log, which is a base of e. So here you can see we have a natural log of 3 equals x plus 1. So I need to get the x by itself. I'm going to subtract 1. And again, if you look, I can use my calculator here. How nice is that? Now this minus 1 doesn't go with the log. So I can do log, and you do have a natural log button here, of 3. And then minus 1. So 0.099 is my approximation for this log.